Okay, class. So in step one, we ran the principal components analysis, okay? And essentially what the principal component analysis does is show me the results of how much variance is explained by each factor. Why? So that you can pick how many you're going to use. So the result of step one is to say, okay, I picked 4. That's the result. Now we move on to step 2, which is called rotation and factor loadings. We will not discuss what rotation is, but you essentially need a rotated solution so that you can actually interpret what each factor is. Okay, so just whenever you see the results of a factor analysis, always use a rotated matrix. So I won't go into the details, but you have to, okay? Because otherwise it will be very difficult to do what we're going to do next. Now, the rotated component matrix, what it shows is, as you see, it shows every one of our relevant attributes, and then it shows component 1 or factor 1, factor 2, factor 3, factor 4, and then it shows a bunch of numbers. So you might think, what on earth are these numbers? These numbers are called factor loadings, okay? And the factor loadings represent the relation among our variables or our attributes and the latent factors, okay? So in particular, the loadings answer the question, how well do our factors explain our variables, okay? And this is easily solved by a concept called communality. The communality of an attribute is the sum of squares of the factor loadings of a variable. So for example, the communality of purely built would be obtained by squaring these 4 numbers and then summing them. Now, however, because we have SPSS, we don't need to do it because it also gives us a communality table. Ignore the initial column, but for example, here we have poorly built, the square of this plus the square of this plus the square of this plus the square of this equals 0.962. So, as you can see, most of the most of the attributes are very well summarized by these 4 factors. But now hold on a second. Even though we chose the 4-factor solution, we will only work with 2 of them. Okay? So in this case, the communality, if you had only 2 factors, has to actually be recomputed. So the communality of poorly built for factors 1 and 2 only is the sum of squares of these both numbers, and by the way, this is a minus, but the square will be the same, and then you will obtain 0.9519. So just in your notes, just put this minus here, and then you'll be fine. So even though you'll see the communality for the whole solution, you need to know, for example, if I ask you what is the communality that the three factors explain, then you know that you need to do the sum of squares of this, and you know that you wouldn't use this piece of information. Okay, oh, excuse me. So this is what the rotated component matrix tells us in terms of how well the factors explain our variables. Okay, so for example, if you had, let's suppose, easy service, and the communality was like 0.05, 0.1, then it might be that even though you have many factors, easy service is not explained by any of them. So then you might have a problem. But in this case, we're doing pretty good. All of them are very well summarized in these 4 factors. So now that we got out of the way, then we can actually get to the fun part, which is how to determine which variable actually goes in which factor. And to assess this, you have to look at the absolute value, okay? Absolute value of the factor loadings. Typically what we do is any loading above 0.6 is taken as belonging to each factor. So let me give you an example. In factor 1, all of those numbers are above 0.6, the absolute value. So for example, minus 0.9, I mean, it's in absolute value is bigger than 0.6, or bigger than or equal than 0.6. So what this means is that attractive, quiet, unreliable, poorly built, prestige, successful, S1, S3, and overall are more strongly related to factor 1. So essentially factor 1 summarizes these variables. Now, all of these are attributes from attractive to poor value. However, this S1 and S3 represents the evaluation of each segment. So in this case, you would say these are the attributes that this factor summarizes, and on top, people that belong to segment 1 and segment 3 have a positive evaluation of this factor because these numbers are positive, and overall and overall this is the factor that represents the most positively evaluated cars. Okay, now I'm going to move on to the rest of the factors. So the second one, these are the by the way, this is not and I'm going to actually correct it right now. Here we go. So these are the ones that are bigger than 0.6. So there we go, there was a small mistake. Now these are for segment 3 and for segment 4. So essentially, because factor 1 is the most important in terms of variance explained, of course most of the attributes are related to this factor, but a good chunk of the attributes are related to the second and very few to the third and fourth. This is why we don't really use them. But now, I mean, this exercise of just figuring if something is bigger than or equal to 0.6 in absolute value, I mean, a machine can do it. Now what we have to do is to go beyond that and to actually try to describe each factor. So now you need to look at the loadings and whether they're positive or negative. So for example, attractive, positive, so this means that factor 1 means that the car's attractive. Quiet, positive, the car's quiet. Unreliable, negative, this means that the car is unreliable, right? So it means that the car is reliable. Poorly built, negative, so this is another double negative. Great build. Prestige, positive, for prestigious people. So, sorry, successful, positive, for successful people. It is, I mean, and by the way, here we're using like as a very loosely worded thing. These numbers mean that segment 1 and segment 3 exhibit an overall a favorable attitude towards this type of cars, towards the cars that are related to component or to factor 1, and also the 0.769 here means that overall these are cars that are greatly evaluated. So for example, if this dimension, if you saw a car that fares very bad on this dimension, that would mean that it will typically not be well evaluated. But now you get to the second factor. Car has to be sporty, actually uncomfortable. So this is a sporty, tiny car, not roomy. But oddly enough, it is easy to service. So this might be like a sporty car that's not that expensive, maybe affordable sports cars, could be Japanese sports cars, for example. Relatively common. And this basically means that the look is somewhat traditional. So you don't want a car that's too crazy. And also segment 2 dislikes this component. So I'm actually going to make the correction right now. Segment 2 dislikes, because it's negative, right? So there was a small mistake there. So there we go. Now this is factor 1, this is factor 2. Factor 3, it says that I mean, what does interesting even mean? I mean, this is not a very good word for an attribute. So this means that this car is not interesting, cheap, and great value. So this might be like really cheap cars. And then the fourth factor says the car's avant-garde, which consumers might not even understand what it is, and that segment 2 also dislikes. So maybe you don't even need this factor. So we will stick to using these two factors to characterize cars. The rest we're going to ignore. So if we had to make a classification, these factors make it very easy. Factor 1 is going to be on the x-axis, so therefore factor 1 is attractive, quiet, reliable, great build. So overall, if factor 1 is positive, it means that the car is of great quality. What is the negative of factor 1? Horrible, noisy, unreliable, poorly built, not for prestigious people, not for successful people, disliked overall. So therefore, on the negative side, we'll have cars of bad quality. Now, factor 2 is a little bit difficult. It's a little bit more difficult to understand. So it's a sporty, but uncomfortable, not roomy. So this is a small sporty car, let's say. Now, what are the negative? What if factor 2 were negative? Then it's not sporty, very comfortable, very roomy, a little bit difficult to service, so this might be an expensive car. The look might be somewhat unconventional, and segment 2 likes it. So it could be a big, roomy car, right? So using this example, we started with a big number of attributes. In particular, we had 19, or actually we had these were the attributes, and then we added segment information, overall evaluation. And then what we did is we ran factor analysis. We figured out that 4 factors were more than enough. Then we went in at the micro level and actually looked at the rotated component matrix and figured out exactly which attribute load onto each factor. And then using this information, we are able to, using our creativity and using our ability in interpreting, we are able to call these factors a certain name. So for example, factor 1 could be quality, and factor 2 could be sportiness. Okay, and of course, very sporty, not very sporty, high quality, not high quality, right? So until then, we are on step 2. Now we are now done with step 2. So now once we have the information on the number of factors we used, we chose to allow for 4. We're going to use 2 for the plot, and then we now know which attributes go into each factor. Now we're going to move on to the step 3, which is obtaining factor scores and then developing the perceptual map. So I will go on to this in the next video so you can see how we do it.